This video is on inverse functions graphically. We have two last examples that we're going to be graphing the inverse and finding the domain and range of the original and the inverse and determining if the inverse is a function. So this example, we have a square root curve. We are going to find the domain and range of this. The domain of the original, so it starts at 0 and it goes off to positive infinity. So the domain is from 0 to positive infinity. And then the range also starts at 0 and goes off to positive infinity. So our range will be 0 to positive infinity. We can automatically find the domain of our inverse by finding the range of the original. We have 0 to positive infinity. The range of the inverse will be the domain of the original, so it will also be 0 to positive infinity. Is the inverse a function? Give two reasons. We want to know if the inverse of this graph will be a function. I don't care about this graph now, like this graph. I want to know about the inverse. So instead of doing the vertical line test, we do the horizontal line test on this graph here. This graph will pass the horizontal line test. That means that the inverse is a function. So one reason that it is a function, that the inverse is a function, is the original graph passes the horizontal line test. So once we graph the inverse in red, we'll be able to do the vertical line test on it to see if it's a function, which it should pass, since we already know it should be an inverse, or it should be a function, So some coordinates of the original, so we can graph the inverse. One coordinate is 0, 0, then 1, 1, then 4, 2. So for the inverse, if we flip those, we'll have 0, 0, 1, 1, but then we'll have 2, 4. We're going to graph 0, 0, 1, 1, but then we're going to graph 2, 4, and then we can connect them. So it does curve, and it does go on forever. So this does start, for the domain, it does start at 0, and it does go right forever. For the range, it starts at the bottom at 0, and it goes up forever. So our domain and range is still correct. Now that we have this graphed, we can do the vertical line test. The vertical line will, in fact, pass. So it is still a function, because now we can see that the inverse passes the vertical line test. This last example is a little tricky because there are multiple curves on this and multiple coordinates. So let's determine the domain and range. The original, the domain will keep going to the left, and it will keep going to the right with no break. That means that the domain is negative infinity to positive infinity. The range of this graph actually starts down at negative 3, and it goes up to positive 3 with no break. So from negative 3 to positive 3. And it is at those coordinates, so they are closed. So we can automatically find our domain and range of the inverse. The domain of the inverse will be that negative 3 to 3. And the range of our inverse will be the infinities. That means that our graph will not go past negative 3 and positive 3 to the left and right, but it will keep going up and down. So it'll have to keep curving, just like this is. It'll curve going this way. Is the inverse a function? Give two reasons. So right now, we're not doing the vertical line test. We want to do, for the inverse, we want to do the horizontal line test. If I drew a horizontal line like this axis, it is crossing the horizontal line. It's crossing the axis more than once. So no, the inverse is not a function. It is not a function because right now this original graph fails the horizontal line test. So now let's try and graph the inverse. We've got to get some coordinates of our original, which is, there are quite a few. There is a coordinate at -5, 0. I'm going to put that up here actually. -5, 0. Then we have the other one at -4, -3. The next one would be at -3, 0. Then we have it at -2, +3. Another one would be at -1, 0. Then at 0, -3. 1, 0. And then like 2, 3. Obviously there are more, and we're just going to have to keep seeing what the pattern is. So for the inverse, we're going to flip these. So we'll have 0, -5, -3, -4, 0, -3, 3, -2, 0, -1, -3, 0, 0, +1, 3, +2. Let's graph the ones we can. 0, -5, so it doesn't go down far enough, so I can't graph that one. -3, -4. That one's a little far down still, so I'm going to come over to here. So 0, -3. I can graph this one, 0, -3. 3, -2. 0, -1. -3, 0. 0, 1. 3, 2. And then we could keep going. So it looks like the curve, we know we want to connect them, but they're going to curve. So we would go more like this. And then if we wanted to keep going, the next one would have to go back to the 0. Then it would have to go back to that 3, -3, back to the 0, back to the +3, back to the 0. So it's just going to keep going back and forth all the way up forever. It'll keep going up forever, but it'll never pass the -3 or that +3. That's how we knew that it would keep going. It would go to the -3, then it would go back to the 0. So the +3, then back to the 0. So you can see that these would continue to go up forever and down forever, but it's not going to go left or right forever. So the domain and range is right. This red graph will not pass that vertical line test. So the inverse graph itself fails the vertical line test. We already knew it wasn't a function, but we can confirm that because that right here, the red graph, is not going to pass that vertical line test. So that is not a function. So again, the horizontal line test is used on the original to determine if the inverse is a function. So use the horizontal line test on the original graph to determine if the inverse will be a function. Because we can determine that before we even graph it. We already had the domain and range of the original, domain and range of the inverse. We already knew if the inverse was a function before we did anything with the inverse.